Hey guys, it's Janine here, and in today's video I'll be showing you how to use Gauss-Jordan elimination to solve a system of linear equations. So in this problem here we have 3 equations and 3 unknowns, and the first thing that we're going to want to do is rewrite this in the form of an augmented matrix. So what we have here is each of the 3 columns here correspond to the coefficients of our equations. So the first column corresponds to the coefficients for x. So here we have a coefficient of 1, 2, and 2. So here we have 1, 2, and 2. And then for the second one, we have the coefficients corresponding to the variable y. So we have 3, 7, and 8 from this 3, 7, and 8 here. And then we have the coefficients for z, 4, 3, and 6 here. And then we have the constant value on the opposite side of the equal sign over here. So what we're going to want to do is get this augmented matrix in row echelon form. And essentially what that means is that the values here are all supposed to be 1, and all the values below the diagonal should be equal to 0. So in order to get this matrix into row echelon form, there are 3 different row operations that we can perform. So the first row operation is that we can replace a row by adding it by a multiple of another row. We can interchange rows, and we can also multiply a row by a non-zero constant. So here let's start off by subtracting the third row with the second row. So row 3 minus row 2. Next thing what we're going to want to do is get rid of this 2 here, so we can do that by subtracting row 2 by 2 times row 1. So from here, we're going to want to get rid of this 1 here. So let's go ahead and do row 3 minus row 2. So next we're going to want to turn this into a 1. So we can do that by multiplying every element of that row by 1/8. So 1/8 times row 3. So now we have our augmented matrix in row echelon form, and now we're going to want to write this as a system of linear equations. So let's start off with the third row. So the third row tells us that z is equal to 2. Our next row tells us y minus 5z is equal to minus 13. So we know what z is. So let's go ahead and plug this in. And then let's solve for y. So we have y equals -3. Now let's write the first row of the augmented matrix as an equation. So we have x plus 3y plus 4z is equal to 3. So we already know what z and y are, so let's go ahead and plug those in here. And then let's solve for x, and we get x is equal to 4. And so our final answer is x is equal to 4, y is equal to -3, and z is equal to 2. And that's it for this video. Thank you guys so much for watching. If you guys like this video, don't forget to give me a thumbs up, and don't forget to subscribe. I'll see you guys in the next one. Bye.